Hi everyone, welcome to lesson 19 of the Advanced Hard Stats course. This lesson is an introduction to hypothesis testing. You will find this skill on page 35 and 36 of the Advanced Hard course spec. This page will be revisited when we look at normal distributions and z-tests. By the end of this lesson, you should understand and correctly use appropriate terminology like null hypothesis, alternative hypothesis, and tail tests. You should know the difference between one-tail and two-tail tests and how to adjust the critical value in response. And you should know how to write an appropriate conclusion after a hypothesis test. Here are the steps that you do in a hypothesis test. The first thing is to write the hypothesis. So maybe medicine A is better than medicine B. Next, you pick a correct hypothesis test. So maybe a one-tailed z-test. Then you calculate a critical value. Maybe the critical value is 1.96. Then you calculate your test statistic. Maybe Z is the one you calculate is 1.24. You compare and conclude. So Z is less than critical Z, therefore not enough evidence to suggest that drug A is better than drug B. Now let's look at each of these steps a bit further. For stating hypothesis, you write two things. You write H0, which is the null hypothesis, and H1, which is the alternative hypothesis. For H0, you're writing what's commonly believed. So for example, it could be drug A's effectiveness is the same as drug B. Or it could be the drug A's effectiveness is 85%, or something like that. H1 is what you're trying to prove. So that could be that drug A is better than drug B in effectiveness, or drug A is worse than drug B in effectiveness. It could be drug A isn't actually 85% effective. Or you could just write drug A is not similar to drug B in effectiveness. And there's a difference in these alternative hypotheses, which are tails. For example, these two are one-tailed because there's a direction to your outcome. So if you do prove this, you're saying A is better than B or A is worse than B. But these are two-tailed. And what that means is that if you do prove this, you're saying that drug A is not actually 85% effective. So you aren't saying it's more or less, it's just not 85% effective. And for the other one, you're saying that drug A's effectiveness is not the same as drug B's effectiveness. And the tails affects your Z value, and we'll go on to that a bit later. Now I want you to try this question down here. The average male height is said to be 68 inches. However, a new large sample shows it to be 70 inches. Write the hypothesis. How I would write this is I do H0 and H1. I would write mu of the mean average male height is commonly believed to be 68, but what the sample shows that it's greater than 68. So I would write mu is greater than 68, and that would be my hypothesis. Here are a bit more on tails. So if it is one tail, you're checking for an effect in only one direction, like seeing if drug A is better than drug B. For two tailed, you're checking for an effect in both directions, like seeing if drug A is different in effectiveness than drug B. Now, how the critical value changes from this is that if we say this whole bit is 95%, and this is one-tailed, if we have the same critical value on the right side as on the left side, and we make that into a two-tailed, instead of it being 95% confident, it would be 90% confident. Because you would have two critical regions. You'd have this critical region here, you'd have this critical region here. So basically, it's harder to prove a two-tailed test at the same confidence as it is to prove a one-tailed test. The next step is picking a correct hypothesis test. And this is done through the data you're given and how it's given to you and some assumptions that you might have to make. So the hypothesis test can range from anywhere from binomial to Poisson, normal, t-test, chi-squared, Wilcoxon, Mann-Whitney, slope parameter, and correlation coefficient. Everything below chi-squared and including chi-squared we haven't covered yet, and I'll cover in the future lesson. That's why they're bolded. But these are the tests. And if you look in the description, I've linked a website with some resources which goes over all the possible tests that you can be asked. Make sure to check that out. Next step is calculating the critical value. So let's say the hypothesis test you were doing is a Z test. It's with a normal distribution. You need to know how confident you want to be. If you want to be 95% confident in a one-tailed direction, it would be 1.64. As in here, 1.64, the critical region is 5%, so the confidence is 95%. If you want to be 90% confident, then it's 1.28. If you want to be 97.5% confident, it's 1.96. But for two-tailed, it's different, and I'll look back on what I talked about before. Let's say you had a normal distribution, and to be 95% confident, this is a critical region you must meet. So this would be 95% confident, and the Z value would be 1.64. And this is one-tailed. One-tailed. But if we say it's two-tailed, but we keep that Z value, what we're doing is we have two critical regions, 1.64, negative 1.64. And because we have two critical regions, and each critical region is 5%, we will only be 90% confident. And that is something you have to pay attention to when you're doing these Z tests. It's an easy mistake to make. The next step is to calculate your test statistic. My only tip here is to be mindful of the continuity correction when you're approximating normality. That's an easy mark to lose. And also to make sure that the question is actually a hypothesis test. Because if it is a hypothesis test, you will be using standard error most likely because it's a sample. However, sometimes a question can use a normal distribution, but just ask you for a probability of, I don't know, x being less than or equal to 5. And it's not a hypothesis test. And because it's not, you don't use sigma over root n. You just use sigma. So make sure you look at that as well. And the next thing is to compare and conclude. So if your critical Z, let's say, is 1.64 and it's a one-tailed test, and your Z statistic is 1.7 here, then you would write 1.7 is greater than 1.64, or the critical Z value. Therefore, sufficient evidence at 95% confidence to reject H0 and suggest that drug A is more efficient than drug B. Make sure to write suggest because it could be a fluke, the data you were using. So it's not 100% guaranteed, it's 95% guaranteed, so it's a suggestion. If your Z test statistic was 1.5, you would write 1.5 is less than 1.64, or 1.5 is less than the critical Z value. Therefore, not enough evidence at 95% confidence to reject H0. That's the end of the lesson. Now you should understand and correctly use appropriate terminology. You should know the difference between a one-tailed and a two-tailed test and how to adjust the critical value in response. And you should know how to write an appropriate conclusion after a hypothesis test.